So in this video we're going to apply the fundamental theorem of calculus to evaluate a definite integral in the case where we have a trigonometric example. So here it says find the area given by the definite integral from 0 to pi over 3 of the secant squared of x dx. So I'm going to rewrite my integral. I have the integral from 0 to pi over 3 of the secant squared of x dx. And then what I need to recognize is that I need an antiderivative, big F of x, of our function f of x. So in this case, the function we're integrating is the secant squared of x. And what I want to recognize is that if I take the function tangent of x, then the derivative of the tangent is the secant squared, which means the antiderivative of the secant squared is the tangent of x. So step 2 is find an antiderivative. So this equals the antiderivative of the secant squared is the tangent of x, or an antiderivative. And then we're going to put our vertical bar in and say to evaluate this from 0 to pi over 3. And this is equal to, now using the fundamental theorem of calculus, we're just going to put the upper bound of integration into our antiderivative. So it's going to be the tangent of pi over 3 from right here. And then it's going to be minus. And then we're going to take that lower bound of integration and plug it into our antiderivative. So we're going to get the tangent of 0. And this is going to equal, so remember the tangent function actually contains the point 0, 0. So between negative pi over 2 and pi over 2, it looks something like this. And it passes through the origin. So the tangent of 0 is just 0. So this will be minus 0. And then what I can remember from trigonometry, if I don't know what this evaluates to, remember that the tangent is the sine over the cosine. So the tangent of pi over 3 is the sine of pi over 3 divided by the cosine of pi over 3. And then if I think about the unit circle, so our circle of radius 1 at an angle of pi over 3 radians, that's going to correspond to the ordered pair. X is 1/2 and y is the square root of 3 over 2. And the y coordinate is the sine of pi over 3, and the x coordinate is the cosine of pi over 3. So we can replace the sine of pi over 3 with the square root of 3 over 2, and we can replace the cosine of pi over 3 with 1/2. And then the 2's are both in the denominator position, so 2 divided by 2 is 1. And the square root of 3 divided by 1 is just the square root of 3. So the area under the curve is the square root of 3. And again, you could verify this by approximating. So even though in the homework you're supposed to give the exact answer, which is just root 3, you could approximate the square root of 3 using a calculator, and then use GeoGebra, like we showed in the previous video, to approximate the area under the curve and verify that the two approximations are the same.